Today's lesson is found on pages 28 and 29 of our textbook, Function Notation. Functions are basic tools that convert input, values of our independent variable, to outputs, values of our dependent variable. We'll use function notation throughout the year. Our first exercise shows this notation in formula or equation form. So there's equation form of a function, there's also table form and graphic form. So exercise number 1 asks us to evaluate each of the following given function definitions and input values. We have f of x equals 5x minus 2. Evaluate f of 3. What does f of 3 equal? That simply means that you replace x in the function above and with 3. So 5 times 3 minus 2, that's 15 minus 2, which is 13. Next, evaluate f of negative 2. Replace x above with negative 2. So 5 times negative 2 minus 2 is negative 10, subtract 2 is negative 12. B, we have the function g of x, defined as x squared plus 4. Evaluate g of 3. We replace x with 3. 3 squared plus 4, that's 9 plus 4, which is 13. And g of 0, 0 squared plus 4 is 0 plus 4, which is 4. H of x equals 2 to the x. Evaluate h of 3. Replacing x with 3, we have 2 to the power of 3, which is the same as 2 times 2 times 2, which is 8. H of negative 2 is going to be 2 to the negative 2, which if you need to use a calculator, that's fine. It's 2 raised to the negative 2 is 0.25. Or 1/4. Do not confuse function notation with multiplication. When we have y equals f of x, y is our output and our rule is f of x, and x is our input. So our two other ways of defining a function can be in the form of a table or a graph. Exercise number 2 has a function in the form of a table. Boiling water at 212 degrees Fahrenheit is left in a room that is 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and are given in the table below. In this scenario, the temperature, capital T, is a function of the number of hours, lowercase h. Because the temperature depends on the number of hours the water has been cooling. So at time 0, our temperature is 212 degrees. After 1 hour, our temperature is 141 degrees. So make sure you kind of interpret the table before you start answering the questions. Evaluate T of 2 and T of 6. T of 2, that's asking us for the temperature after 2 hours. So time 2 hours, our temperature is 104. T of 6, asking us for the temperature, the output after an input of 6 hours. Here's 6 hours, temperature is 68 degrees Fahrenheit. For what value of h, so at what hour is the temperature 76 degrees? So we're looking for a temperature of 76, which occurs right here, and that is after 4 hours. So when h equals 4, the temperature is 76. Let me just go back and take my blue dot from there and put it here. Because then when we were evaluating T of 2, at time 2 hours, that's the temperature. Between what two consecutive hours will T of H equal 100? So T of H, so we're looking for the hours when the temperature is 100, or between what 2 hours is the temperature 100? Well, after 2 hours it's 104, and then after 3 it's 85. So 100 falls between these two. So that is 2 and 3 hours. Between 2 and 3 hours. Exercise 3, we have a function in the form of a graph. The function y equals f of x is defined by the graph shown below. Use this graph to answer the following questions. Evaluate f of -1. Well, first off, on our grid here, we do not have numbers, so I always like to put numbers down. And if there's no scale indicated, then we're going by ones. Okay, now back to our question. F of -1. We go to an input of -1 on the graph is right here. So our output is also -1. F of 1. X value of 1, where are we on the graph? Right up here. The output is 4. F of 5. An input of 5. Here we are on the graph. An output of -4. Evaluate f of 0. F of 0 is equal to an input of 0. An input of 0 has an output of 3. F of 0 corresponds to the y-intercept. Where the graph crosses the y-axis. It's called the y-intercept. See what values of x solve the equation f of x equals 0. So we're looking for the x values that have an output of 0. Well, an output of 0 is anything on the x-axis is a y value of 0. So we have an x value of -1, an x value of 3, and an x value of 7. So that was -1, 3, and 7. What special features on the graph does the set of x values that solve f of x equal to 0 correspond to? These are what we call x-intercepts. It's where the graph crosses the x-axis. The equation for the x-axis is y equals 0. Between what two consecutive integers does the largest solution to f of x equals 3 lie? F of x equals 3. So f of x you can replace with y if you want. So we're looking for an output of 3. y equals 3 is going to be this horizontal line, and between what two consecutive integers does the largest solution, getting a little messy here, we want the largest solution. So let's see, our graph crosses my blue line y equals 3 here, here, and here at 3 places, and the largest solution would be the highest x values here, which would be between the integers of 7 and 8. Right, this point right here is between x values 7 and 8. Exercise 4. For a function y equals g of x, it is known that g of negative 2 is equal to 7. Which of the following points must lie in the graph of g of x? So if g of negative 2 equals 7, then that means negative 2 is the x value and 7 is the output. 7 would be the output. Or the y value. So it would be the point negative 2, comma 7. Coordinate pairs are always alphabetical, right? X, Y. So negative 2, 7, which is option 2. And now exercise number 5. Physics students drop a ball from the top of a 50-foot high building and model its height off the ground as a function of time with the equation h of t is equal to 50 minus 16t squared. Using a table on a calculator, determine the nearest tenth of a second when the ball hits the ground. Write the table of outputs to support our answer. Okay, so we're using a calculator here, so we go to y equals, and I'll key in the equation, 50 minus 16, and we use x squared. And they're dropping it from a height of 50 feet. So if I just press table, usually, I don't know why mine was so far down, usually it would give us this. So after 1 second, it is at 34 feet. After 2 seconds, it's at negative 14, so it's kind of gone into the ground. Well, we're not going to, the ball is not going to go in under the ground. So we need to change our table setting here in that I do second window, and right now our table is going by ones. So let's change that to, we want tenths, so let's go 0.1. Press enter, and now second graph. So it's going to be on the ground when the height is closest to 0. So let's copy this portion of the table. So at 1.6 seconds, it is 9.04 feet from the ground. At 1.7, it's 3.76. And at 1.8 seconds, it is negative 1.84. So we'll say at 1.8 seconds. Sketch a graph of the height versus time using second trace. Calculate the 0 on the calculator. determine the same as above to nearest hundredth. Okay, so we want to sketch a graph of this, and so we're going to, it only requires less than 2 seconds before it's on the ground. So we're going to change our window, our X max, I'll put at, well, let me go to the min first. The min would be 0, the max 5, and then Y is our height. Y min 0 and max is 50. Okay, so I have it in Y equals. I want to go to window, X min 0, max 5. The scale, I'm going to go by ones. The Y min 0, the max 50. And I'll go this Y scale by tens. Now if I press graph, that's what it looks like. And now it says using second trace, calc 2, 0 on the calculator. We do just that. Let's see if I can somehow zoom out of here a bit and see more of the calculator. Second trace, option 2, enter. It asks for a left bound, so we are looking for the time at which it's on the ground. So I'm using the right arrow, holding down. No, I'm way too far over. I'm after a time of 3 seconds. So now I'll go to the left arrow, and I'm waiting for my cursor to start to come into view. There it is. And I need to be to the left of the point, which it is. So I press enter. And now it asks for a right bound, so I need to move that cursor to the right of this point. So I'm just pressing on the right arrow. It's to the right of the point, I can't see it. I press enter. Then for the guess, we just press enter. And there we have 1.767767, comma 0. 1.767767, comma 0 is the point. And rounding to the nearest hundredth, the 6 is in the hundreds, that'd be 1.77. And I'll do a quick sketch of my graph. And this point here, coordinates are here.